In this video, we're going to be taking a look at levels of measurement. And basically, what levels of measurement refers to is that depending on the type of data that you have, there are different kinds of mathematical operations that either may or may not make sense at that level. And there are 4 levels of measurement. The lowest level of measurement is called the nominal level. It's the one that we can do the least with. At the nominal level of measurement, the data consist of names, labels, or categories. Okay, so this is essentially definitely qualitative data rather than quantitative data. And because at the nominal level the data consists of names, labels, or categories, it's the case that no meaningful mathematics can be performed. We can't add and subtract data values. We can't average data values. We can't do any of that with nominal level data because the data are not numeric at this level. Okay, so that's the lowest level of measurement. The next level up from there is the ordinal level of measurement. And at the ordinal level, the order of data points is meaningful. But differences between data values are meaningless. And here, when we talk about differences, we're actually talking about the mathematical definition of the word difference, which means subtraction. Okay, so at the ordinal level, the order of data points is meaningful, meaning the order that we put them in matters, but the differences between data values are meaningless. We can't compute subtraction as an operation between data values. So to give you an example, one of the things that frequently comes up at the ordinal level of measurement is, let's say we're measuring employee performance. And we're doing that on a scale of, let's say, below average, average, and above average. So if we rated, let's say, 50 employees, could we put those data values in an order that would be meaningful? Well, sure, we could order them from either lowest performance to highest or highest to lowest, but the order is important. Below average is a lower ranked measurement than average, which is a lower ranked measurement than above average. So the order here is important. However, because this is still not numeric data, we can't do any meaningful subtraction, right? We can't subtract average from below average. It doesn't work that way. So this would be an example of something that qualifies at the ordinal level because the order matters, but we can't subtract. Okay. The next level up, the next highest level when we're talking about levels of measurement, is the interval level. And at the interval level of measurement, the data can be ordered. So it still includes the definition of ordinal, but now the differences between data values are meaningful. Actually, rather than but here, we're going to say and. So the data can be ordered and differences between data values are meaningful. But ratios are not. Okay, so at the interval level, we can put the data in order. We can subtract pieces of data, but we can't divide. When we take ratios, we're talking about dividing data. So we can't divide data values and get something that's meaningful. to give you an example of something that frequently comes up at the interval level, calendar year is something that would be at an interval level measurement. So let's say that we had a bunch of years and we had, I don't know, the year, 1200, the year 2400, which obviously we're not there yet, 1998, 2001, these kinds of things. Okay, calendar year. Now, could we put these in order? And would that order be meaningful? Well, sure. If we put them in order, 1200 would come first, if we do from lowest to highest, then 1998, then 2001, then 2400. And the order would matter because it's in chronological order. That would be a meaningful order to put them in. Can we take differences between data values and get something meaningful? Well, sure. 1998, 2001, if we subtract those two, we get a difference of 3, and 3 years have passed from 1998 to 2001. So that makes sense. Ratios, however, don't really make sense when we're talking about calendar year. I can take 2400 and divide it by 1200 and get 2 as the ratio. But that's not to say that the year 2400 is somehow twice as late as the year 1200. That ratio of 2 is actually meaningless in this context. So at the interval level, we can put the data in order, we can subtract, but if we try to divide, the values that we get are not necessarily correlating to any real world construct. Okay, they don't have a real world meaning. Then our last level, and it's the one that we're kind of hoping for as statisticians because it's the one that we can do the most math with, is the ratio level of measurement. Okay. So at the ratio level, the data can be ordered. Differences and ratios can be taken. And there's what's called a meaningful zero. Okay, so let's talk about this a little bit. We can put data in order. We already talked about what that meant. Differences, meaning we can subtract. Ratios, meaning that we can divide here and actually get something that makes real world sense. And there's a meaningful zero. Meaningful zero is one of those terms that frequently bothers students because the value doesn't actually need to be the value 0, which is why I have it in quotation marks here. But meaningful zero simply means that there's a point past which you wouldn't be able to measure that value anymore. So there is a point past which measurement of the variable ceases. Okay, and I'll give you an example here. Let's say we're talking about, we're going to look at some stock market data, and we have a stock's closing price. Actually, no, scrap that. Let's say that we are working in a vineyard, and we're going to be looking at cases of wine. And so we have the case price for a case of wine, and it's in dollars. Okay. So if we had a bunch of cases in our warehouse, and so we had a bunch of different data values, I don't know, I have no idea what case prices for wine would be, but we have a bunch of, let's say 50 different cases, and we have a bunch of different prices in dollars. Could we put those in order, either from smallest to largest or largest to smallest? Yes, we could, and that order would be meaningful. More expensive cases would be at the top of the list, less expensive cases would be at the bottom. Could we take differences? Would it make sense, for example, to say that one case costs $50 more than the other? Well, sure, that makes sense. If we subtract and we come up with a difference of 50, that's telling us that one case is more expensive than another by $50. Would it also make sense to take a ratio? Would we be able to say, for example, that one case costs 3 times as much as another case? Absolutely, we could do that. And there's a meaningful zero. There is a point past which we don't measure case price, right? Chances are we don't have any cases in our warehouse that we're willing to pay people to take away. We don't have any cases with a negative price. So the lowest possible reasonable price for a case of wine would be 0. Okay, we wouldn't go into the negatives. And actually, we probably wouldn't even hit 0. We'd probably only have prices that were above 0. So again, this meaningful 0, the value doesn't necessarily have to be 0, but there just has to be a point past which we stop measuring that variable. Okay, and it doesn't even have to be the case that that point is part of your data set. There just has to be a theoretical point where you don't keep measuring that variable. Okay, and those are our 4 levels of measurement: nominal, the lowest; ordinal, then interval, and then ratio.